Good morning. Today we are also continuing to look at functions, but representing them as graphs, and this is lesson 1.7. So it says first, graph the function y equals 1/2 x. So we've looked at equations like this before, with a domain, meaning that's what we're going to plug in. We're going to plug in 0, 2, 4, 6, and 8. So if we're going to plug something in, we better make a table. I'm going to make an xy table, and it tells us for what we're plugging in for x, we're plugging in a 0, a 2, a 4, 6, and 8. So we're plugging those in here for x. So first, if x is 0, 1/2 times 0 is just 0. 1/2 times 2, you can either multiply the top and divide the bottom. 1 times 2 is 2, and 2 divided by 2 is 1. Or think, what's half of 2? Well, half of 2 is 1. Same thing with 4. 1/2 times 4, well, 1 times 4 is 4. 4 divided by 2 is 2. Or just think, what's half of 4? 2. Some of you might be able to see the pattern. 0, 1, 2, we should have a 3 and a 4, because half of 6 is 3 and half of 8 is 4, just like the equation says. So a quick review of plotting points. This is our x-axis. This is our y-axis. If you look at the letters x and y, the letter y is longer. It goes up and down. So we need to start plotting these. X, y, this is really a point 0, 0. 0, 0, we call that the origin in the middle. Then we have to plot this point 2, 1. X is 2 to the right, y is up 1 right there. Then 4, 2. 1, 2, 3, 4 to the right, up 2. Then 6, 3. 6 to the right on our x-axis, and then y is up 3. And then last, 8, 4, 8, comma 4, 8 to the right, up 4, xy. There we go. That's all we have to do. We graphed that function. We're going to do the same thing here. Here's our equation or our function. And we need to plug these numbers in for x. So here I'm going to make a table. X is 0, 1, 2, 3, 4, and 5. Let's plug these in right here for x. So first it says 10 minus 2 times x, and x is 0. We cannot do 10 minus 2 first. Remember, we have to follow the order of operations. So we have to do our multiplication first. 2 times 0 is just 0. So 10 minus 0 is 0. Then plugging in a 1, we have 10 minus 2 times 1, plugging that in just for x. Again, multiplication first. 2 times 1 is just 2. So 10 minus 2 is 8. Then plugging in a 2, 10 minus 2 times 2. We're plugging in a 2 here for x. 2 times 2 is 4. So 10 minus 4 is 6. Oops, I made a mistake back here. 10 minus 0 is 10. So it should be a 10. If I plug in a 3 now, 10 minus 2 times 3, well, 2 times 3 is 6. So 10 minus 6 is 4. Again, we see the pattern. 10, 8, 6, 4. We're going down by 2, so next we should have 2 and then 0. So let's plot these. X, y. X is 0, y is 10. So x, we're not going left and right, we're going up at 10. That's right at the top. Then 1, 8. X is 1, so 1 to the right. And up 8. Then 2 on our x-axis, and y is 6, so 2 to the right, up 6. 3 to the right, up 4. Here's 3, up 1, 2, 3, 4. 4 to the right, up 2. And then last, x is 5, so 5 to the right and 0. Not up and down, just right there. So we have graphed this function. Flip over to the next slide. This problem, we're not actually graphing anything because it's already graphed for us. We are just analyzing a graph, or looking at it, making some guesses, some interpretations based on the points. So it says, the graph shows guitar sales in millions of dollars for a chain of music stores for the period 1999 to 2005. Identify the independent variable and the dependent variable. I'm going to do that right now. So our independent variable is what we would plug into our equation. Our dependent variable is what we would get out. Remember, these are looking for words. Later, if we have to describe our domain and range, that would be actual numbers. So our independent variable, what we would plug in for x, here's our x-axis, well, it says years since 1999. So that's our independent variable, how many years we have. Our dependent variable, what we get out, well, our sales is dependent on the number of years it's been. So our sales, or our y-axis, in millions. So now it says, describe how sales changed over the period and how you would expect sales in 2006 to compare to sales in 2005. Well, over the period of time, as time goes on, what's happening? Our sales are going up. So we just need to say that in words. You can say, as the years go on, the number of dollars we spend that we earn is more. You could say from year 0 to year 6, the sales increase from 0.4 to about 1.2 million. Variety of ways you can say this. I'm just going to say, as the years goes on, as the years go on, the number of sales in millions goes up. Another word, better word, we could say is increases. Then it also says, expect how you would, or describe how you would expect sales in 2006 to compare to 2005. Well, if this first year 0 is 1999, this is year 2000, 2001, 2002, 2003, 2004, 2005. So year 6 is really 2005. So on the edge of our graph here would really be 2006. So we would expect sales to be up here somewhere. So we could just say we would expect sales, you can either say to be at about, these are going up by 0.2, so this would be about 1.4. To be about 1.4, 1.5, or you could say we would expect the sales to continue to increase. If you want to put about 1.5, you can, $1 million in sales. So we've answered all the questions, that's it. Next, it says write a rule for the function. The word for a rule is an equation. Write an equation for the function represented by the graph. Identify the domain, what we put in, and the range, what we get out. So in order to write an equation, like we did the other day, we need a table, an XY table. So I'm going to make a table based on the points that are here. Here's X, here's Y. So if I look at this point right here at the top, X is really at a 0 down here. Y is at, right here, this would be 5. At this point, X is at a 1. Y is at a 4. At this point, X is at 2. Y is at, these go by 1, so 3. This next point, X is 3, Y is 2. And the last point, X is 4, Y is 1. So like we've done in the past, figuring out our pattern, because our X's go by 1s, our pattern here is subtract 1, so our equation is Y equals negative 1X, going down, negative. And then look for where X is a 0, Y is a 5, so our equation would be at plus 5. Okay? There's our equation. If we wanted to list the domain, we could, but guess what, you guys? They're right here. This is our domain, 0, 1, 2, 3, and 4. And then our range, what we get out for Y, these numbers, 5, 4, 3, 2, and 1. Let's do the same thing over here. I'm going to create my XY table. These ones now, these go by 5s, 5, 10, 15, 20, 25. And then these go by 1s, 1, 2, 3, 4, 5. So this first point, x is at a 1, y is at 10. Our next point, x is 2, y is 15. Our next point, x is 3, y is 20. And our last point, x is 4, y is 25. So our pattern to get from one number to the next, we're going up by 5s. So our equation is y equals 5x. But there's no 0 in our table, so we need to go backwards. Instead of adding 5, subtract 5, and we should be at 5. So in our table, x is 0, y is 5. So 5x plus 5. All right, we've got this one. It says write a rule for the function. Again, another word for rule is an equation. And then identify the domain and range. So this one, they're not labeled. If they're not, you can assume they go by 1s. So here on our x-axis, this would be 1, 2, 3, 4, 5, 6. And here, 1, 2, 3, 4, 5, 6. And here, -1, -2, -3, and so on. So if I convert this into a table so I can make an equation eventually, this first point up here, x is really at a 0, y is at 3. Our next point, x is 1 and y is 1. Third point, we have x is 2, y is at -1. Our next point, x is at 3, y is at -3. And then our last point, x is 4, y is at -5. So looking for our pattern, so we can write an equation. We're going down, so I know it's subtracting. From 3 to 1, I subtract 2. It works. So our equation is -2x. And then look for where x is a 0, y is 3, so it's a +3. If we list out our domain and range like it asks, our domain we had 0, 1, 2, 3, and 4. And our range we got out 3, 1, -1, -3, and -5. So this last slide is just different ways we can represent a function. Ignore this, we don't need to worry about that one. We've looked at equations. We could take an equation and a list of x's and plug them in and get the y, so we can go from an equation to a table. And we also know how to go from a table to a graph, taking these and plotting them 1, 1, and so on. But we also know how to go this way, taking a graph and making a table from it like we just did, and then from that table writing an equation. So if you have any of these 3 parts, you can actually figure out all 3 of them. Alright, that is it. Your homework for today is actually out of the book, and it is on graph paper. So make sure you write down all of these problems and go ahead and get started.